they arguing among each other about these ideas. So they are really showing that they have accepted those norms. And the teacher is doing a lot of things to keep this going. She says, try to explain in such a manner that everybody can understand. Listen carefully and see if you understand. So the focus is on understanding. Who thinks he can explain what Amber and Vicky tried to do? So, sorry. She moves to other students to rephrase what the solution has been. Do you have something to add? And after the interruption, without telling them how many hours could you explain to them how they could figure that out? So she's turning that into a new question. And all the times you have all these interjections which are focusing on talking to each other, thinking of their own reasoning, explaining, and so forth. So that's about social norms. The other thing we learned, I think, is that there's a problem with task and ego orientation or motivation. Students have to be, maybe they accept the norms and they know what they have to do, but they have to be willing to do it. They have to be willing to invest effort in solving problems, discussing solutions, and the underlying ideas. So there's two sorts of orientation or motivation. So the ego orientation, where students are very conscious of the way he or she might be perceived by others. And the other one is the task orientations, where the student's main concern is about the task itself, how to solve it, and so forth. And the problem with ego orientation is students may even stop thinking about a problem or discussing a problem because they are afraid that other students will laugh at them if they say something wrong. So it's very important that they are motivated to shift to task orientation. And you can cultivate that by creating a classroom culture where the students' measure of success is by comparing their results with earlier results. Like if you're an amateur musician, you will be looking if you're improving yourself, not comparing to some norm. By the way, the latter results is also from research from some Paul Kopp. Let me go to the next one. Cultivating mathematical interest. And that's something we found in a teaching experiment also in Nashville. In realistic mathematics education, it looks like as if it's all about pragmatic interest. Someone has a problem and wants to resolve. But to get on a higher level of thinking about your solution and what you can do about it, you also have a sort of mathematical interest. What can I do with what I found? What's the general principle here? Does it always work? Can I change it to attack other problems? And so that's the only way to go further in a vertical mathematization. And a teacher can cultivate this interest by showing genuine interest in the student's mathematical reasoning. And it would argue that this mathematical interest is a prerequisite for reinvention. The students have to have a motive to try to get to other higher level solutions. Framing topics for discussion. I hope these are not the things, and I'm quite sure these are not the things you're telling next day, Paul, but again, I'm referring to you. This is a teaching experiment, also we did in Nashville, and here came to the fore the need for framing topics for discussion. What we often do is comparing solution procedures. I hope that the students can see that there's a smarter solution that you can use, that you can and start using that. But what Paul focused on is that you have to, as a teacher, to identify differences in mathematical understanding and have a classroom discussion about those differences. And that's what meant by framing mathematical issues as topics for discussion. An example was students were measuring a carpet, how long it is by toe to toe, measuring with their feet. And there were two procedures. And the one was just 1, 2, and so forth, with each foot. And the other one was counting, starting by the second one. And now you could say, well, we just talk to the students, explain that the first one is the correct one. But if you look at the mathematical thinking that is behind this, then in the first situation, students are counting steps. And in the second situations, there's the thinking of accumulation of the distance. Each time you put a foot forward, you get a longer distance. So they're really measuring. So this issue has to be discussed in the classroom between students to get on the mathematical issue that's at stake here. Well, I have some trouble with this machine. The other point I think that was developed was the notion of a hypothetical learning strategy by Simon. And he thought about this idea of constructivism and then realized, so the solution is not to tell students something because they construct their own thinking. So how can I guide or steer the students' thinking? And the solution was this idea of a hypothetical learning trajectory. So you anticipate what students might be thinking and see if that happens and see how that relates to your goal. So in full, think through the mathematical activities the students might engage in as they participate in the envisioned instructional activities and how these relate to the learning goals. And then, of course, this is hypothetical. You expect them to do some things, and then you have to check if that's true and adjust. So, his answer to how make students invent what you want them to invent is this idea of anticipating on their thinking. And this entails a shift from an observer's point of view as a teacher to an actor's point of view of the students. And I'd like to illustrate it with Calvin and Hobbes again. This is an observer's point of view of Calvin, which is puppet tiger Hobbes. And this is the actor's point of view, how he sees it himself. And so we have always tried to think of how students see the world by themselves. And well, this hypothetical learning trajectory, you can see it as a thought experiment of what might be going on next moment in the classroom, see what happens, and then adjust. So these are key things I think that are important in trying to get an inquiring classroom culture. I wanted to say a few things, also I'm running out of time, about what type of support could be given. If you think that teachers are going to develop these hypothetical learning strategies, they need a framework of reference, of thinking about these things. They need an idea of how this thinking might develop. And we call that local instruction theories. And that's a theory about a possible learning process and the means of support. And I think that's the kind of support that is very useful for teachers, that they have an idea how learning fractions or learning multiplication of fractions might proceed and how you could support this. So I think it's important work to develop those local instruction theories. And then the teacher has to translate it to his or her classroom, those students, this moment of time. So it's not a prescription, it's a framework of reference. This is what I mentioned before. Just a few words on teacher professionalization. There's a guy, Michael Fullen, who in the 70s wrote an important article pointing to the fact that this idea of ready-made curricula doesn't really work in classrooms. Teachers interpret it differently, do different things. So yeah, and since then he's been working on curriculum innovation, and that's for about 30 years or even more. And his conclusion now is that if you look at all those innovations, most of the time, if you come back after 5 years or more, nothing has changed. So there's no effect of most curriculum innovations. And that's a sobering lesson, I think. And the problem, he argues, is teachers don't get feedback on what they do in their own classrooms. Most of the time there are pull-out sessions and the teacher goes back to his or her classroom, does things or doesn't, whether he wants or not, but not knowing if what he or she is doing is what was intended. Not getting praise if he is doing something marvelous, or critique if it's not the case. So what is needed that teachers in classrooms are visited. And the best way, he argues, is a collaboration between teachers that includes visiting each other classrooms. And so you need groups of teachers who commit themselves to improving their teaching. So the starting point is in the commitment of the teachers. They have to want to change, they have to do something new to improve, whatever. And it's very much like the idea of the Japanese lesson studies. And then another point on the teacher change, a lot of research, at least in the Netherlands, shows that teachers are willing to learn, willing to experiment if they have ownership. It's their problem, it's something they want to do, then they change. And we often come from the outside with all kinds of solutions for problems they didn't realize they had. So you need this intrinsic motivation. And in the lesson studies, that's what is being used in Japan. Teachers work together and try to find out who you can do certain things and go to each other classrooms and see how it works out, improve it, and so forth. Just the last word on strategy. I think one thing is ambition. We have to put a spot on the horizon, as the language is, and we need to get the support of the wider society. I'm rather convinced that as long as the wider society is not convinced of the need of understanding and things like that, the whole system will say the same. And doing that, we have to think of changes in our society. We are developing a digital society where a lot of mathematics is done by machines, and more mathematics than ever is being done, and that has consequences for mathematics education. I think we have to start in a zone of proximal development of teachers, things they can handle with help, with support of others, and not be too ambitious at once, but to go step by step. And I want to point to an interesting approach, which is developed by Cathy Vosno, the same where you saw the video from, and she did a lot of teacher training, workshops, and so forth. And she found that the teachers who wanted to try out these new approaches needed instructional activities to work with. So she started, together with Maarten Dolk, developing instructional materials for about 2 weeks, which teachers could use next to their normal textbook. So they get a feel and get some experience. And then she developed more and more of these units, and now they're almost filling a whole curriculum. That's, I think, an approach in which you can grow into a new way of teaching. And then I think I'll skip the wrap-up and just say thank you.